Hi, question number 2. It is given that fn is equal to 2 to the 3n plus 8 to the n minus 1. By simplifying fk plus 1 or otherwise, prove by mathematical induction that fn is divisible by 9 for every positive integer n, 6 marks. Now, I'm going to check the base case to start with. So let n is equal to 1, and therefore we've got f1 is equal to 2 to the 3 times 1 plus 8 to the 1 minus 1, which is then 2 to the 3 is 8 plus 8 to the power 0 is 1, and that's going to be 9. Therefore, f1 is divisible by 9. That's true. Now what we're going to do, we're going to assume that fk, which is equal to 2 to the 3k plus 8 to the k minus 1, is also divisible by 9. And now, where we go with this, we are told that we need to simplify fk plus fk plus 1. So let's do that. Fk plus fk plus 1. And we know that fk was found to be 2 to the power of 3k plus 8 to the power of k minus 1 plus fk plus 1. Now fk plus 1, if we have to work this out, is going to be 2 to the power of 3n, n is k plus 1, plus 8 to the power of k plus 1 minus 1. Maybe I should have done that separately, but that doesn't matter because I'm just taking this straight away. 2 to the power of 3k plus 8 power k minus 1 plus 2 to the power of 3k plus 3, you distribute this, plus 8 to the power of k, and of course 2 to the power of 3k plus 2 to the power of 3k times 2 to the power of 3. We use the law of indices here. We split this in two, and that's what we get. And also I have plus 8 to the power of k minus 1 plus 8 to the power of k minus 1 as well times 8 to the power of 1, because if you multiply these you should be able to get that. K minus 1 plus 1 is k. So again, we're using the law of indices here. This is like saying 2 power 3k is 1 times 2 power 3k plus 1, times 2 power 3k plus this is 8 plus 2 power 3k plus here we've got again 1 into 8 power k minus 1 plus 8 to power 1 is 8 into 8 power k minus 1. So basically 8 plus 1 is 9 times 2 to the power of 3k plus 1 plus 8 is 9 plus, and factorize this, you got 8 to the power of k minus 1. So what do we have here? We've got 9 into 2 to the power of 3k plus plus 8 to the power of k minus 1. We can see that this is divisible by 9. Divisible by 9. So what conclusion do we draw here? Is that if fk was assumed to be divisible by 9, is divisible by 9, so is fk plus 1, alright, as we've seen, because if you add these two, this should be divisible by 9 here, and therefore this alone here is divisible by 9, okay. And now also f1 is divisible by 9, and hence what can we deduce? What can we conclude rather? Fn is divisible okay, by 9, alright, for every integer integer n being greater or equal to 1. So this is what we've been asked to prove. Here we are. Question is taken from June 2018, Further Maths, code 9231, paper 1. Take care.